good morning. Well, it depends where you're listening from, but it should be Saturday morning in England, and it's about 11:15 at night, somewhere around Australia and New Zealand. And the idea is that we could do a little bit of maths revision on the very long road to the lead up to the GCSE, which is going to happen this summer. And where better to start than number? We've got a few questions here, and on a Saturday morning, they're designed to keep you fresh and to make sure you haven't dropped any of those little bits of knowledge along the way. And feel free that if you are listening, you can join in with your own questions if you join a server, and I'll drop a link in the description of this one, so if you want to come along every Saturday morning around the same time, that you can send some questions in ahead and we'll go through them. So without further ado, let's get started with Frank. So Frank earns £12 per hour and he works for 40 hours a week. So we might say there's a sum here. That's 40 multiplied by 12. And we want to be able to find a total. We don't always write total, but this is a calculator paper. You don't necessarily have to use a calculator for something like this, do you? So per week, we're getting £480. 40 hours times 12. And he saves a fifth. There's all fancy ways of doing this, isn't there? Finding a fifth. We can divide by 5. So we can write some ways down. Finding a fifth. We divide by 5. We times by 1/5, which is equivalent to multiplying by the decimal, which is 0.2. Which is going to be my chosen one here, because I just did a calculation and I have this result on my calculator. So I'm going to keep it there and multiply it by 0.2. But I'm not going to press equals yet, because I don't know what the next part of the question is. So I'm just going to make sure I don't need the 80% and I need the 20%. He saves a fifth each week, and how many weeks to take him to save? Okay, so this fifth represents savings. So we want to know what that fifth is, and then we've got a couple of methods to find out how fast we can get to 500. So yes, I will press equals, and we get £96. That's not bad. £96 a week. Can't argue. So now how many weeks till this becomes 500? Well, we could say 96 and 180, 192, etc. And we can keep adding 96 until we get to the 500, and we can say how many it was. But there's probably a quick way of doing this if you have a calculator. You keep that 96 on your calculator, and we're going to type 500 divided by the 96, which actually is going to be divided by answer. Okay. It gives us a decimal, which is 5.2. So how are you going to write 5.208 weeks? If you think about it in your head, it's like having these multiples. You've got the week 1, week 2. So when we get to 500, it requires 5 weeks and a little bit more, implying that at 5 weeks we're not quite there. So we have to wait till week 6. So in these sort of cases, we have to understand the context, and we're going to be rounding up to the nearest whole. Brilliant. Okay. So if you haven't figured it already by the thumbnail, we're looking at number today. So the idea is we go through different chapters. And this week is number, so more number questions have arrived. A floor measures 4.75 meters by 3.5. So we should probably draw a rectangle, because floors are usually rectangular. Usually. 4.75 the long, and 3.5 the side. It is to be covered with square carpet tiles of sides 25 centimeters. Okay. Might be useful to have that as a diagram. I don't know if you're visual when you do this, but let's make it all in meters, shall we? So we have a square carpet tile, and we might want to write that so we don't forget what carpet tile. So we don't forget what it is. It's to be covered with that size, and tiles are sold in boxes of 16. So we can say times 16 in a box. All these little bits I write down helps my understanding of the question. Feel free to copy me. How many boxes are needed? Very good question. Very good question, sir. We can cut tiles. It doesn't say anything about tiles being put down in holes, which is a wholly different thing. If we can cut the tiles, it means we only need to focus on total surface area. So calculation-wise, 4.75 times 3.5 is going to give us the area here. And of course, you could draw your tiles on, right? And you could say 0.25 across, and you could say 4.75 divided by 0.25, and you know you're going to get 19 tiles, okay? 19 that way. And then it's 0.25 down this side. So 3.5 divided by 0.25 is 14 tiles down that way. Okay, so that's one way of looking at it. But I'm going to look at it in terms of surface area. So a total surface area is 16.625 meters squared. Those are in meters. Always get told, don't you? Don't forget your units, eh? And the carpet tiles themselves are over here, 0.25 squared, which is 0.0625. So if we do 16.625 divided by the answer that I just calculated, 0.0625, I'm going to write that down actually. 16.625 over 0.0625. That's the area of the big shape and the area of the small shape. See how many go in. Apparently it's 266 tiles. Now that's what we needed to know, but it's not the end of the question. Can we confirm that 14 times 19 is 266? Yes, it is. So if you did our old method of just trying to draw it inside, and it'll still work. The question could be considered bad in that regard because like it's a whole number, and it's probably better to do the method we've got over here for the more complicated situations in life. But nevertheless, many different ways to get there. How many boxes is the question? Okay, so the boxes come in 16s. Let's do our old trick from that last question. We're going to do 266 divided by how many in a box, and it gives us obviously 16.625. So how many boxes do we need? We need 16 and a bit. Okay, we need 6.65, so that's a bit more than half of another box. And typically, it actually doesn't say, but typically these questions you can only buy whole boxes. That's kind of the wisdom in life, actually. And so in that regard, we have to round it up to 17 boxes. I suppose we're going to sell a few spare tiles or keep them for if they break. Or in a process, it could be a good thing if you're doing it and then like the quality of the tile is not the best. So maybe one breaks and then you're happy for these spares. Spare tiles. Anyway, cool. As a product of prime factors has to come up, right? So let's see if we can remember this. As the product of prime factors, 60 is 2 squared times 3 times 5. What number is represented by 2 times 3 squared times 5? Well, that's fairly straightforward. These are prime numbers, and when we multiply them together, we could say this is 4, and this is 15. We know that's obviously 60. We could do our sums in a different way. So writing 60 in terms of prime numbers is useful because it reveals facts about the structure. And it's a really cool way to be able to cancel fractions down and figure out information about whether a number is square or not if it's a really big one. Prime numbers are really useful. If I were to go back into GCSE and, maybe I didn't go past GCSE, but I would think prime numbers more important than they were. I just thought I'll just remember them. But they are so important to the universe and well worth remembering and looking into. What number is represented by this? We're just going to multiply it. So we've got 2 times 9 times 5. Looking for quick ways of doing this because you don't need to do it in the particular order. So I'm going to multiply what helps me make sense rather than 2 times 9 and then times 5. Find the lowest common multiple, the LCM, of 60 and 48. So it's really useful. We're going to use the information up here. 48, we're going to have to draw a prime factor tree, or you can just do prime factors. Like I'm going to have a go right now. I know that 48 is even, so that's going to be 24. That's 24 is even as well, so that's 12. Maybe I'll get it 2 cubed, which is 8, and then 8 times 6, and 6 is 3 times 2, so actually it's going to be another 2 times 3. So that's 16 times 3. So you can do it in your head if you know your prime numbers, but the general way of doing it is to sort of split it like this, underline it if it's a prime, and then you're back to counting how many 2s and 3s and multiplying together just like we have up there. All good. So now we have all this information. How do we find an LCM? We're actually going to find the HCF, the highest common factor, and the LCM in 1. It's a really cool method, so we may as well do both because by doing the method for 1, I use Venn diagrams. I know there's probably there are ways of doing it with just a list, but we're going to go for the visual. 48, 60, and well done if you've already done this and you're like way ahead and you're thinking this is too easy. Now we've got to look at what's in common. I'm just going to do it thoroughly. I'm assuming that you've forgotten this, right? Wouldn't be fair to just do a load of questions on the assumption that you've forgotten it and then not tell you how to pick it back up. Although that is important, you need to go and do your own research sometimes. My biggest tip to you studying GCSE is just write down the topics you don't know. Don't be afraid of the ones you don't know. And if you're in class, you don't know how to do it, put your hand up and say, what's this topic? That's all you do. Or you could even do it after the lesson, right? So after the lesson is less, I don't know, embarrassing? Whatever it is. I don't have a problem myself, but I understand it can be nerve-wracking. So look, we've got these two lists. What goes into both? We definitely can pick out two 2s. So I'm going to put 2 squared in the middle. There's definitely a 3 in both. So that goes in the middle as well. So now we're left with the unique parts. So with the 60, the unique part is 5. And with the 48 that we have, it's 2 squared. Awesome. So we should have the same amount of 2s that are uniquely represented, because, the ones that appeared in both, we just put them once in the middle. And we find in the middle that if we multiply these together, we have the HCF. So that'd be 4 times 3, which is 12. So useful. Highest common factor, so the number that goes into both of them, that is the biggest. And the LCM, let's clear this, is where we take all of these in the center and multiply them together. Now I always do the HCF first, which means this is a done deal. So I have the 2 squared, which is 4, multiplied by the middle bit, which is 12 times 5. Well, depending on how you want to play this, if we did the 48, we did the 60, I think we'll play it that way. So 4 times 60, 5 times 12, and then 4 times 6 is 200, is 24, so 240. And that would be the LCM. This is the lowest number that they both go into. So if we did the times tables of those two numbers, 60 and 48, first number you'd get to that was in both lists would be this number here. Fantastic. Express the following numbers as a product of prime factors. So in fact, we've done 60 in a sense. I'll do it anyway. Who am I to question the great exam? Could be a question. So 2 squared times 3 times 5. Just we knew it. And 96 begs for a separate space. If it's even, start with 2. Okay, don't overcomplicate things for yourself. Just going back, we just did 48. So this part here is going to be exactly the same. Look at that. You've always got to find, you've got to work clever in life, yeah? Double check it works. 248 should work, shouldn't it? Save yourself some time. So how many 2s? 1, 2, 3, 4, 5. And 1, 3. So these can be written in this special way. All right. Now, use your calculator to work out the value of this. That's not bad, but we have to write down all the figures. Are there any things that we need to be aware of here? I think so. Now, we're going to be pressing the button which looks like this. This is the fraction button. So the first thing we're going to do is that. And what's going to happen when we do that is 2 boxes are going to turn up like this. But I'm going to extend my boxes to what I think they'll roughly be like by the time I'm done. And we're going to use the navigation key to, well, it starts at the top anyway. So get to the top, and we're at 6.27 times 4.52. No problem. Now I want it to do that first, so I'm going to put that in brackets. I'm just going to make sure that this gets sorted as the numerator separately to the denominator. So it's gone in as brackets. Let's get rid of that. Cool. And then the bottom, also in brackets. I don't want it to do anything odd like divide by just 4.81. I want it to divide by the result of both. So call me paranoid, but I put that in brackets as well. I'll tell you something. If rubbish goes in a calculator, rubbish will come out. It's not looking after you. It's not got your back. And well, what you need to be able to do is not let it wander astray. You know, guide it. Tell it what to do. Once that's in the calculator, I'm going to press equals. Now, some of these modern calculators will give you maybe an answer that looks like this. Not the best. Thankfully, this does not. 1.96. Hopefully, you're working along with me, and you're double checking your answers with me. If you disagree with any, you tell me now. It says write all of them down. So we love these questions if they come up, surely. Write your answer to part A in appropriate degree of accuracy. It's hard to tell what appropriate is, isn't it? Because there's no context. But I don't think you're going to go wrong if you decide to write 1.9. Actually, if you do write 1.96 would be better. 1.96 to 2 decimal places. GCSE, don't want to go more than 2 decimal places when you're rounding. I don't think I've really seen that. So that's a good tip. We'll leave it there. Use approximations to estimate the value. Now, this probably won't be in a calculator, but if it is, it's there to trick you, because you'll get your calculator out and you'll suddenly get the perfect answer, but it tells you to estimate. Please don't forget that one in the exam. So estimation means before we do anything, we're going to round to one significant figure. Okay, let's have a go. 212 to one significant figure is 2, because the 1 isn't big enough, but all the rest to the decimal are going to turn into zeros. Multiplied by 7, but that is going to go up to 8, and the decimal and beyond is ignored, so there you go. This is rounding to one significant figure. Do you remember I said if you don't know how to do this, you write down the topic and you go find a video on how to do it. Round into significant figures is what you're doing. And the bottom works with the decimals. That is going to turn to 0.4 and nothing more. So this could be quite easy to do now compared to before. So we've got our 200 times 8, which is 1600. And remember, this is only going to be an estimate. 4/10. Now, if I did have a calculator, this would be pretty straightforward to do. But if I don't, my method would be to turn the decimal number on the bottom into a fraction. And remembering that this represents a division, we can remember that if we divide by a number, it's the same as multiplying by its reciprocal. So this would be 1600. Instead of dividing by 4/10, multiply by 10 over 4. This is the same thing here. So divisions can get tricky, so we can convert, as long as we're very careful what is being divided, fraction on the bottom. Let's get rid of this. And there's a few ways of doing this. I'm going to actually divide this by 4 first. So we get 400 times 10, and then 4,000. And this is your estimate. So in a sense, you could write approximately equal to 4,000. I wonder how far we are out. So you can use a calculator at this point. And yeah, well, it's a lot out actually. The real answer is 4576.876, etc. Maybe we're on the wrong side of the thousands, but that's the estimation. You can definitely see that it's an underestimate. All right, so sometimes they ask you about whether it's an overestimate or an underestimate. Type the original in if you can. If you don't, and it's a calculator question, just use your wit and think 200 has been made smaller. 7.88 is only a slight bit bigger, but not as much as 212 has been made smaller. And then the 0.365 has been made bigger. And anything bigger on the denominator is going to make it smaller overall, fair enough, but it's not that much difference. The biggest is that 200. It's been made much smaller. And that's why we end up with 4,000 instead of 4,500-ish. But that's the question. That's the skill. We're looking to see, can you use estimation? Okay, so we set up a Christmas tree with 2 sets of twinkling lights. A would twinkle every 3 seconds, and then B would twinkle every 4. So what would that look like? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Where roughly this? So every 3 seconds. So here's 1 second, 2 seconds, 3 seconds. 1, 2, 3. 1, 2, 3. 1, 2, 3. And this other one would twinkle every 4. So that would be 1, 2, 3, 4. And 1, 2, 3, 4. I'm like visualizing this. You don't have to do this. Oh, look. They're at the same time. This is really good visual to see that it's sort of catching up, and at some point it'll probably flash at the same time. Right, so these are seconds across the bottom. But how do we do it with numbers? Because there's actually a really easy way of doing that. So how many times in a minute will both be sets be twinkling at the same time? We want to know how often they repeat, right? So that would be done with the shortest time it takes them to reset, which is going to be this cycle here. Because now they're starting again. 1, 2, 3. We've got the 3 repeating there. And then the 4 there, which is just like this section here. So we're looking at that first period of reset, which is represented here. We want to get some numbers there. I mean, I could count, but it's pretty easy to see if I did my 3 times table. And then my 4. What am I doing? And then my 4. That at 12 seconds, we are on the money. Okay. So this is the amount, this is when it repeats at the earliest time. And we're asked how many times in a minute? Well, 1 minute has 60 seconds. So 60 divided by 12 is 5. So 5 times. P and Q are prime numbers such that PQ cubed is 250. Find the values of P and Q. Ooh, what are you thinking? You're thinking straight away, I know my prime numbers. Let's try some. 2 times 3 cubed. Okay, that's 2 times 27, 54. Well, it's bigger than that. I think you'd be there a long time if you did it that way. But if it's true that 250 can be written in prime numbers like this, it must mean that we can go backwards from 250. So 250 is 50 times 5. That's a prime number. And then 50 is 5 times 10. There's another prime number, so I'm thinking Q is 5. And then 10 is 2 and 5. So we've fully completed. And when we look at it, we have P, which is going to be the 2, times 5 cubed, because there's 3 of those, making P 2 and Q 5. Beautiful. The number 40 can be written as this, where M and N are prime numbers. Find the value of M and N. There you go. This is an actual exam question, by the way. So do your worst. You can't pause the video, but I'll natter on for a second, and I'm sure you'll be very quick at this. So 40, 2 and 20, 2 and 10, 2 and 5. Let's clean that up, give everyone a chance to do the actual question, which is 2. This is a clue already, see? It's probably an easier way then if we know that 2 is there. Or a different way, probably an easier. 3 2s times a 5. It says find the value of m. M is 3 and n is 5. Estimate the answer to this. Okay, you know how to estimate now. I wonder if that's a little bit difficult, huh? Have a go. You're going to round to one significant figure first. This one, 3, because the 9. Everything before, or up to, shall I say, the decimal place becomes 0, and everything after the decimal place is gone. 11. That's going to be 1, 0. Beautiful. And on the bottom, 0 point, let's draw a line on the first significant, 0, 4. That's going to become. Did you get that? I do hope so. So, easier now. Is it any good? I don't know. We'll figure it out later. How do we do this on a calculator is easy, but without one, a bit harder. So, we could turn it to a fraction would be my tip. And while we're at it, how do you turn this to a fraction? This is the tenths column, and this is the 100ths column. So it is a matter of 100ths, and in total there are 4 100ths. Okay, that is the number as a fraction. And if we sort out the square root of 4 over 100, it could be written separately, like this. This topic, if you want to understand why, is called surds. Okay, so when we deal with these square roots and all the rules, we can split them up like this to be 2 over 10. So that's going to be 300 divided by 2 over 10. And like what we did earlier, we can say if we divide by something, it's the same as multiplying by the reciprocal. And the reciprocal of a fraction is just flip it like this. Okay, so we could divide by 2 and times by 10, or we could just say 10 divided by 2 is 5. 5 times 300 is 1500. Now, are you interested in the actual value? Divided by the, I'm going to put in brackets, square root 0.038. Okay, surprising. Before I tell you the actual answer, do you think this is an overestimate or an underestimate? So considering that this went up a little bit, this went down a little bit, does it cancel out? And this, that got bigger a little bit. The question is proportionally, which one had changed the most? 0.4 and here 1.9. So the down wins, making it smaller. But then down here, we've got an interesting thing going on. We've got the square root. And when you square root a number, the bigger it is, like the bigger the answer is. So this has become bigger. But we've got the inverse effect, haven't we? So a bigger number there, but it's a decimal. Meaning overall, wow, what do you guess? I'm going to write the answer now. Absolutely. So the effect of making that has made it smaller. As let me write what this is, because 953, this is the actual answer, right? The full accuracy, and this is our estimate. So quite rightly, we'll just do this. So it's made it smaller, and for a couple of reasons. The battle on the top, when you have a smaller numerator, and then this is larger, both of those scenarios would make the overall result a lot smaller. And so that's what we see. What are the least and greatest number of sweets that can be found in these jars? Have I done everything? Yeah, good. So they've been rounded. It's very strange because it means they're counting like half a sweet or something. I don't know. But if we keep to whole numbers of sweets, I'll think about what we're going to do. But this is one significant figure, right? So before it was 70, could have been more. 71, 72, could have been less. Okay, so we'll try and visualize what's going on here. And we could have rounded 69, it would have been 70. Could have rounded 68, yeah, that's fine. 67, yeah, that's fine. 66, yeah, because the reason I'm saying yeah, it's fine is because the second number, it makes it closer to 70, right? The rule is if it's 5 or above, it will go up. Well, let's look at the top. 71. Oh, wait, one more. 64. It's not 614, it's 64. But if we round it to one significant figure, it becomes 60. Okay, let's make that a bit bigger. So there's your cutoff point. Okay, so write that a bit better. 65 is the lowest. Okay, there is a way of doing this a bit easier. I'm just giving you the idea. 73, 74, and 75. Now they're all going to go down. This is going to go up. So technically it's 74. But when we talk about the boundary, typically where it's measuring something, we would be talking 74.9999, which is the same as 75. And then we do like a strict inequality. But I'm going to say for this one, it's whole numbers. All right, because they're sweets, they're whole sweets. So I'm going to say that the largest, the greatest is 74. Okay, and the lowest is 65. What about 100 then? It's a bit more difficult. 101, 102, 103. Okay, we can probably skip a few to 95. We can skip up to, what would be important, 109. Maybe 105, the first one. So what would stay as 100 if we were to cut it off at 1? This one would. This one would. This one would. Okay, so would 5 make any difference? No. So we're already finding an interesting situation where we need to go a little bit more. 109? Well, no, still 100. 110. If we cut that off, that's not going to make it, is it? It's going to keep it as a 1. So actually we're looking at something like 1, 5. So let's do 2. 1, 4, 0. 1, 5, 0. So we ran into one significant figure, which is very peculiar. Does very funny things. For example, 103, there's our one significant figure. The next one along is 0, so it becomes 100. And according to this, is that true? It goes all the way up to 120 like that? Cut it off there, keep the 1. This doesn't go up. Yeah, so it's very strange happenings at the top. So when we get to 150, I'm only talking in whole numbers, that is a pretty high number, and it's going to make it go over the top, because that's going to round it up to 200. The next one down is going to be 149. I'm not going to look at 140, because it's clear that that's the same, but we've got 9 at the end, so that's the highest it could possibly be. Right there. Different with the 90s. Very strange goes on around 100. With the 90s, we just act as normal. This is going to, let's see what effect it has. So 95, we're going to keep that as a first significant figure. But the 5 is going to make it go up to 10. And then the rest are going to be 0. So yeah, it does go to 100. So essentially, we're looking for that number. Let's just try one a bit lower and see what happens. 94, we're going to keep the 9, but the 4 doesn't make it go up, so it goes to 90. So yeah, we've definitely found it. 95 is the lowest. But that's a very strange range, I always find. An argument to not use significant figures, perhaps. Anyway. Bit of substitution. All I can say with substitution is be careful with the negatives. And if you really want to be sure, and there are people out there that are always getting this wrong, you want to be really sure, use extra brackets. So if there's something that needs to be replaced, like A, give it its own bracket. Same as C squared. A is -2 and C is -5. Deal with this very carefully, but there are a couple of things to know. When everything is plus or take away, you don't need the brackets. And when everything is multiply, you also don't need to worry. Do it in whatever order you want. So I'm going to do this as -2 plus -5 by looking at that plus minus that's right next to each other. It becomes -2, -5. Now I see these as I'm going to start at -2 and I'm going to go to the left 5. So I'm going to be at -7. However you want to do it. But we have to do these brackets first. So we figure that out and then we square. Thankfully for us, everything squared is a positive, so 49. Please feel free to work ahead. -2 plus 3. Also tricky. We have to do what's in the bracket first. So -2 plus 3 is 1. And all these little tricky things, it looks confusing, but do it one at a time. Now, what is going on here? Whenever you see a minus at the front, it's essentially -1 times. So it's a multiply. That means we have to do this first, which is the bracket. Well, that's great. It becomes 1 positive times -1. And the negatives will get their revenge. Negative times a positive is going to give us a -1 overall. Okay, next. -2 plus 3 multiplied by -5. So I'll do brackets. 1 times -5. Love it. Because there's a positive times a negative, okay, so don't forget. And lastly, definitely brackets time, definitely. Although you could know that everything squared is positive, that does help. So that's going to become 4. I almost just ignore the negative. 9, take away. Now, that is a negative inside, but the result is a positive 25. And therefore, it's still take away. Okay? There's no point in making mistakes at this stage. 7 plus 5 is 12. And we're going to go into the negative, because 25 is bigger than 13. Okay. Now, nobody knew this live stream was coming. It just went live. I think I gave 10 minutes in advance, so no worries. So therefore, there is no one with questions, and you've made number 1 stream shorter as a result. But hopefully, this is a nice little listen in a Saturday morning to keep you fresh and keep you on track with those basics. Hopefully, I'll see you next Saturday. If you want to join the Discord, then you can go over to a channel which I do a lot of collaboration with, called Maths Explained. It's on the screen. And you can see very clearly a link to the Discord. And I'm in there quite frequently. I will help. You can drop your questions in there and we'll have a go at them. It can even be on Saturday's live stream. But that's one way of doing it. Or secondly, drop the question into Patreon. Patreon is a lovely community that I have. You don't need to... sorry, let's get a new screen. Patreon, you don't need to pay to join. Okay, and what is it actually? It's patreon.com/T formula. And yeah, so you don't need to pay. You could just join and communicate and say, look, this question, please have a go. Like, I need to know on a Saturday, or just do it on the chat. And but if you did want to support the channel, there are ways of doing it. I try to make it really fun. So if you do support, you will get free gifts coming your way, supplied by Patreon and designed by me, to remember this wonderful year of study that you've had. Anyone watching? It's been great to help you. Have a great day.